After studying this module, you shall be able to understand the concept of environmental Kuznets curve (EKC), learn about the origin of the EKC phenomenon, identify the delinking and relinking hypothesis, analyze EKC from a critical perspective, and appreciate the need to study EKC as a global phenomenon.
Protection of the global environment and greater economic development are the two legitimate interests of the global community. What we are witnessing today is an era of trade openness, global economic interdependence, and unprecedented competition amongst countries pushing for further convergence. It has been believed and learned from experience that trade and investment liberalization can stimulate economic growth and foster greater welfare. But the sustainability of such growth has been repeatedly questioned. The serious environmental damage caused in the process of growth acceleration leads to one to believe that economic development and the quality of the environment are inherently conflicting. The environmental Kuznets curve is one phenomenon which counters this dichotomy between economic development and the environment. It offers greater economic growth as a means to solve environmental problems.
Economic development and quality environment are inherently conflicting due to the damage to the environment caused by the accelerating growth process. The environmental Kuznets curve is one phenomenon which counters this dichotomy between development and environment as it offers greater economic growth as a means to solve environmental problems. Let us understand the concept of EKC. According to the EKC hypothesis, environmental damage increases in the early stages of economic development but diminishes once nations reach higher levels of income, suggesting that the relationship between income and environmental degradation takes the shape of an inverted U. This happens because developed countries have the necessary technologies for pollution abatement and also the necessary capital for implementing such technologies. According to the EKC theory, economic growth leads to environmental deterioration in the early stages. In the end, the best and the only way to attain a decent environment in most countries is to become rich. In the early stages of economic growth process, there is a positive relationship between economic growth and environmental degradation. With further economic growth, environmental degradation starts reducing.
The basic philosophy of the EKC theory is that although economic growth usually leads to environmental degradation in the early stages of economic growth, in the end, the best and probably the only way to attain a decent environment in most of the countries is to become rich. In the early stages of economic growth, the primary production dominates. There is an abundance of natural resources and limited generation of waste, but in the course of development and through industrialization, economies experience natural resource depletion and waste accumulation. These are some of the causes for environmental degradation as economic growth and development takes place. During this phase, of accelerated growth, there is a positive relationship between economic growth and environmental degradation. With further economic growth, however, the growth of the services sector improves, and there is improved technology, there is information diffusion, and all of these factors are responsible for limiting the use of materials, that is the material bias in an economy, and this results in reduced environmental degradation.
Let us look at this hypothetical EKC. The turning point represents that level of income beyond which environmental degradation can be delinked from the process of economic growth. This is called the threshold level.
The environmental Kuznets curve is named after the Nobel laureate Simon Kuznets, who purported an inverted U-shaped relationship between economic growth and income inequality. Intrigued by the character of changes in the personal distribution of income, Kuznets analyzed for USA, England, and Germany the income distribution pattern and came to the general conclusion that the relative distribution of income in a rather broad sense was moving towards income equality after the First World War. He explained that a change in the income inequality was a result of the high income modern sector of the economy that was growing at the cost of the expense of the low income traditional sector. This sectoral shift is supposed to result in an inverted U-shaped inequality over a period of time. In other words, as a nation undergoes industrialization and urbanization, opportunities for those with money increase, while there is an influx of cheap labor from rural areas into the urban areas, and they get better paid jobs. As a result, in the urban areas, in the cities, there are more and more of people shifting from the rural areas. Under these conditions, the urban population would run the full gamut of low income positions of recent entrants to the economic peak of the established top income groups. This would result in urban income inequalities being far wider than those in the rural population, which was organized on a relatively small scale and with the help of small enterprises and farming. But post the turbulent phase of industrialization, the dynamism of the growing and free economic society would enable the rise in the income share of the lower income groups in the urban population as well. So also the middle classes would emerge in the process when the service sector expands, and accordingly the inequalities would then be expected to decrease. This results in the inverted U-shaped relationship between income distribution or income inequalities and economic growth.
The conditions for weak delinking, strong delinking, and relinking define in absolute terms the relationship between economic growth and environmental stress over time. Delinking refers to the process whereby aggregate economic activity gives rise to reduced environmental impacts. Delinking can take two forms in a growing economy: weak and strong. Weak delinking implies that environmental stress intensity of GDP decreases over time. Delinking in its weak relative form implies change in environmental degradation with respect to GDP is negative. For delinking to be strong, environmental degradation ED must fall over time. So delinking in its strong absolute form implies change in environmental degradation is negative. Delinking embraces two dimensions: composition effect and technique effect. The composition effect is associated with shifts in production and or consumption patterns towards sectors or industries that are less environmentally damaging. This is also called dematerialization. The technique effect is associated with changes in production processes and product design achieved through improvements in technology that allow less use of inputs per unit of output, use of less environmentally intensive inputs, less generation of wastes, etc.
At the early stage of economic development, the environment deteriorates as a result of increasing production and natural resource extraction. This is called the scale effect, which explains the upward trend in the EKC. At this stage, production transforms from primary production to industrial production. As economic development accelerates with the takeoff of industrialization, the rate of resource depletion exceeds the rate of resource generation and waste accumulation increases. But at the higher levels of economic development, structural change towards information intensive industry and services uh, happens, which is called the composition effect. Coupled with better technology, which is known as the technique effect, positive income elasticity for environmental goods, a better institutional framework and governance, etc., bring about a downturn in the EKC. In other words, at this stage, environmental degradation will be delinked from the process of economic development. Assuming the EKC hypothesis holds true, one can still doubt if the observed improvement in environmental quality will sustain in the long run. If such improvements could not be extrapolated into the future, delinking would only be a temporary phenomenon. This implies that there might come an income level where there would be technology and economic upper bounds to the improvement of environmentally efficient technologies. At least until the further breakthroughs take place in research and development, there would be this tendency which applies an upper limit. So therefore, till the time that we wait for newer and more intensive applications of technology and better environmental policies to check the environmental degradation, we may expect that the trend gets reversed. At this stage, the delinking condition would not hold good any longer. The environmental degradation would, with respect to economic growth, again become positive, and this is known as the relinking hypothesis.
Relinking can be defined as the empirical validation of a process in which pollution intensity has been stabilized or starts to rise again. Relinking can take two forms, weak and strong. Weak relinking implies that the environmental stress intensity of the GDP increases over time. Relinking in its weak relative form implies that change in environmental degradation with respect to GDP is positive. In case of strong relinking, the environmental impact increases over time and in its strong absolute form implies that change in environmental degradation is positive. Let us now illustrate the delinking and relinking process with the help of a diagram. The entire process signifies that EKC would not hold in the long run. What one can foresee is an N-shaped curve which exhibits the same inverted U-shaped pattern initially. We can see as GDP increases, environmental degradation increases as well, represented by area A, B. In B, there is a positive relation between environmental degradation ED and GDP as delinking is weak in this stage, but with further development, the delinking process gets strong and thus ED decreases with further development. But after a certain level of income is reached, the relationship between economic development and pollution becomes positive again. As we can see in area D, relinking process starts to build up, and finally in area E, we can see again a positive relation between ED and GDP. If the last stage of relinking does not take place, area E in the figure, one can identify the inverted U-shaped relationship between environmental degradation and economic development as posited by the EKC phenomenon.
Since 1991, when economists first reported a systematic relationship between income changes and environmental quality, the relationship known as environmental Kuznets curve has become a standard fare in technical conversation about environmental policy. Central to the discussions on economic development and environment has been the dimension of trade and investment, liberalization, and which has been resulting in an entire development debate being revisited from the point of view of trade, economic development, and the environment. The defenders of free trade have often relied upon the EKC hypothesis and argued that trade generated resources, in particular the financial resources, will enable economies to make investments for the environmental protection and conservation. This would otherwise be unaffordable in the case of the poorer economies. It is also contended that trade can improve environmental outcomes by encouraging greater efficiency, diffusing abatement technologies, and raising environmental awareness. Additionally, the capital abundant developed countries which with investable resources and improved technologies can attract pollution intensive industries to adhere to stricter environmental standards and thus bring about a further improvement in the environment. Slide 29. The environmental Kuznets curve, popularly known as EKC, is designed to explain the dependence of the environmental degradation on the level of economic development. It is typically described for a given country or a cross section of countries as a relationship between per capita income and selected indicators of the environment. The EKC implies that global pollution is driven largely by the development efforts of less developed countries as they traverse up the rising part of the EKC. On the other hand, the purported downturn of the EKC at higher levels of per capita income imply that developed countries are contributing to the amelioration of the global environmental degradation. But this proposition fails to emphasize the level of global environmental degradation, which should be conceived as a worldwide phenomenon to be captured by a more composite index, emphasizing the wider notion of environmental degradation and not just pollution. Uh, this will facilitate the understanding of its relationship to economic development across the world. Thus, what is required is the computation of a more comprehensive aggregate measure of environmental degradation, of which pollutants would only be a subset. This measure is then related to a more complete measure of economic development rather than per capita income alone. This would enable the assessment and measurement of the EKC as a global phenomenon.
Over the years, EKC theory has been tested and validated for certain countries using specific indicators of environmental degradation. But there are many who are critical of the EKC phenomenon. Now we will discuss the main points of concern. The inverted U shape of EKC is taken for granted and empirically examined for countries by relating individual degraders with individual indicators of economic development. Linking individual pollutants to the level of per capita income, as done in most cases, gives an incomplete picture because many pollutants are related to each other and to other indicators of environmental degradation. Furthermore, a country's per capita income may be only an imperfect indicator of its development. There are also econometric issues. The data used in many EKC studies is patchy in coverage or poor in quality. Moreover, there is no sufficient data on all countries over a long period. This fact restricts seriously any empirical results while attempting to find an income pollution pattern for all countries. The implicit assumption that a unidirectional causality runs from income to the indicator of environmental degradation ignores the fact that environmental degradation may reversely affect the process of economic growth. The validity of the EKC pattern is contingent on the type of pollutant considered. The inverted U shape has been supported mostly when the pollutants in question are associated with low and local short term abatement costs. Examples of such pollutants are sulfur dioxide, particulates, etc. No apparent patterns have been found for pollutants with long term effects such as CO2 emissions. The fundamental EKC assumptions, such that the world income is normally distributed and that all countries are expected to follow a common developmental pattern, are questionable. Structural changes, technical progress, and international trade may sufficiently explain an EKC pattern, but these forces pertain to the production side of an economy without taking into consideration the consumption side. If the needs of domestic consumption are satisfied by imports, then this effect is not taken into account in an EKC analysis focusing only on domestic production. In the light of these concerns, the validity of EKC as a universal phenomenon remains questionable. Empirical analysis reveals that it may apply to select pollutants and to certain countries, assuming different forms inverted U, U shaped, N shaped, or monotonic. Therefore, there are bounds to its validity. It is also worth mentioning that most empirical work has focused on individual EKCs only, but owing to the global implications of environmental degradation, more efforts should be made to examine the validity of EKC as a global phenomenon by relating a composite index of environmental degradation to a better measure of economic development across countries.
a significant contribution in the direction of constructing a global environmental Kuznets curve called the GEKC was made by Jha and Murthy. They developed a composite environmental degradation index known as EDI and then related this index to a better measure of economic development, namely the Human Development Index, which is popularly known. Uh, the purpose was to develop a global EKC across 174 countries with the help of the relationship between the Environmental Degradation Index and the HDI rank of these countries. They found evidence for the existence of an inverted N-shaped global EKC and in the process discovered that there was extreme inequality amongst the contribution of low, medium and high HDI country groups to the global environmental degradation. In fact, low HDI countries effectively ameliorated the global environmental degradation, while the high HDI countries excessively exacerbated the degradation. Thus, validation of the EKC as a global phenomenon is necessary to render clarity on the tools and the circumstances in which the process of economic growth may improve the environment and thereby assist policy makers in understanding the evolution and the environment of environmental quality over time. This is the significance of the study of global EKC.
Let us now summarize what we have learned in this module. According to the EKC hypothesis, environmental damage increases in the early stages of economic development but diminishes once nations reach higher levels of income. The conditions for weak delinking, strong delinking, and relinking define in absolute terms the relationship between economic growth and environmental stress over time. The entire process of delinking and relinking signifies that EKC would not hold in the long run. Many are critical of the EKC phenomenon because it is based on questionable assumptions and its validity is contingent on the type of pollutant. Identification of a global EKC calls for computation of a more comprehensive aggregate measure of environmental degradation and relating it to a more complete measure of economic development in comparison to per capita income.